So we have 8 basic theorems of Boolean algebra that we will now highlight. And the first one is represented by 2 parallel switches. That one is whenever we have a 1, we are equating it to a closed switch or on position, which is, we are also saying that to be true. And therefore, if you have one of the switches is true or on, then we have another switch that is being ORed, that is taken through an OR operation. Then the output here will always be a 1, meaning that this 1 means that the switch will always be open no matter whether A is on or off. That is one of the 8 basic theorems of Boolean algebra, and you'll find it quite useful. Another one is if this switch now is open, meaning that it is not closed, equivalent to a false, that means the output that you are going to measure here, assume that you have some bulb connected. That is the one that you are measuring with you are measuring the bulb as your Y, and your operation 0 or A is the one that you want to test. The bulb is connected to the cells or the energy or source. Therefore, if we are sure that one switch is open, then this bulb will only light if switch A is closed. Otherwise, it will always remain off. And for that reason, we are saying that the output of Y is entirely relying on A. On the other hand, in a similar manner, just like we have seen, you have a bulb here and you have taken it through an energy source, and therefore whether A is open or closed, since the other switch in parallel is closed, then this output Y will always be on. That is why we are saying it is equals to 1, because it is dependent on this one switch. Another of the 8 Boolean theorems is that of assume that these are switches that are the same label, and therefore if they are the same label, we are saying that they are controlled simultaneously. I normally equate this one as a double switch, a switch that will connect 2 connections via one turn. For that reason, assume that again you have your bulb with the energy source here. Dependent on what is the status of this connection, which is entirely A, if you connect it, the bulb will light. If you turn it off, the bulb will not light. And therefore, you are saying that A or A is equivalent to A, and that is very quite easy to figure out or to associate. The other one is similarly here, that these 2 switches work in opposite of each other, and our bulb is here. Therefore, if these 2 switches work in opposite, that means that when this one is off, the other one is open, or rather, when this one is on, this one will always be off, because they are always working in opposite of each other. Therefore, if that be the case, what we are sure about is that this connection will always be on, because if this one is open, this one is closed. If this one is closed, this one is open. And for that reason, the output will always be a 1. And that is why we are seeing that A or A bar or A prime will always be a 1 no matter what. So similarly, we have 2 switches in series. Of course, you can see that these ones are based on OR operation, and these 4 are going to be based on AND operation. And for that reason, we say that if you have 0.A, meaning that it is being ANDed, then if you connect your bulb there with the energy source, what that will mean is that that bulb will never light, no matter what, because this switch 0 is off, it is never turned on, becomes a constant. But if whether A is on or off, that means that this bulb will never light. Similarly, you have your energy source here, and you have your bulb, and one switch is always on. For that reason, the output Y will only be dependent on this A, because if this A is on, the bulb will light, and if A is off, the bulb will not light. For that reason, we say 1.A is equals to A. So finally, we have another 2 switches in series that are controlled by the same variable A. And therefore, the only thing we want to figure out is that if you have a bulb here, if this A is closed, that means the other A is closed, and for that reason your output Y will light. On the other hand, if the A is open, then the bulb will not light, and therefore our output is completely dependent on only A. That is what this switch means. Similarly, we have one switch is acting opposite of the other, and for that reason this thing will never light. For instance, you have your bulb there, you have your energy source, and you have connected up your two switches as such. When this one is closed, this one is open. When this one is open, this one is closed. For that reason, it will always remain off. Whether you like it or not, it doesn't have any other option. The solution, it will always be a 0 or an off. That is the 8 basic theorems of Boolean algebra. That means that they are coming from the two major gate operations, that is the OR operation and the AND operation. And these are quite significant theorems that we will need to memorize, because they will come in quite handy, particularly when you are simplifying logic operations or Boolean expressions. So these are the 8, and they are quite easy to remember. If you asked what happens when you have A dot A bar, this will always be this operation, and this will always be a 0. What about when you have B dot B? This variable remains the same whether you're using A or B. And as we have seen, this is as two switches which are in series, and for that reason you know that this will always be dependent on B, and this is what this means. So whenever we see a dot, notice that this is a series operation. Whenever you see a plus, this is equivalent to an OR operation, and therefore you can be able to figure out what will happen to a bulb when you have the two switches in parallel as such. Then we discuss the concepts of commutative, associative, and distributive laws. These are quite common. Same way we deal with them in mathematics. We know that A or B is equivalent to B or A. They don't change. Or AB is equivalent to BA. So that is quite the same. It is quite intuitive. The associative laws also are quite intuitive, because whether you put the bracket here or in the first two, they are going to be the same. And similarly for the AND operation, this is the OR operation, this is the AND operation. That doesn't change. And we'll see the symbols that are used for representing these gate operations. The distributive rules also says that you can combine an OR gate with an AND gate through a bracket, and when you do that, this can be equivalent to one AND gate and another AND gate combined with an OR gate.